In this video, I'm going to provide a full course of how you take an existing SimPy model and build that into a deployable web app using Streamlit. This is going to be based on our peer-reviewed tutorial paper, which is available in NIHR Open. I'll leave a link to that in the chat below, and feel free to check that out as well as the open peer reviews about our work. I'm going to show you how to create a simple Streamlit app. That's going to have multiple components. We're going to have an interactive simulation page where we can select parameters for our simulation model, vary our simulation model warm-up parameters, data collection period, and the number of replications we run. We'll be able to run that model and obtain some quantitative results for key performance measures in our simulation. And I'll throw in some Plotly code so that you can have an interactive histogram where you can select different performance measures and see what that looks like across the replications. Another useful feature is we'll look at how do we implement batch experimentation in our model. So we're going to provide a template for your users to download. That's going to be a CSV file that will contain the parameters of the simulation model across a number of experiments. Your users will be able to quickly change those and add additional experiments if they would like. And we'll make it simple for your users to simply click and drag the experiments into your app. They'll be loaded up. They can then, again, vary the number of replications they want to run and then obtain results across all of those different scenarios. And again, simple click to download those to your computer. Finally, I'll just give you a little bit of advice about including an open license with your app so that people are clear about the terms and conditions for using it, as well as an about page that might be useful, for example, to linking to your YouTube channel, which may have videos about how you built the simulation model in the first place. Finally, we'll learn how to deploy our app to Streamlit Community Cloud. If you're enjoying this type of content and would like to see more, feel free to click the like button and subscribe to the channel. All of the code for our SimPy app is available online in the GitHub repository, and I'll provide a link to that in the description below. If you head over there, you can either clone the repository or download as a zip file to your machine. Once you've got it on your machine, you'll see that there is a Conda environment file there that contains all of the software we're going to need to install, including Streamlit. Once you've got the code on your machine, open a terminal and navigate to the directory containing the code and install the Conda virtual environment. That'll take a few minutes to install with Conda. If you're interested in speeding that up, you could try using Mamba instead. If that's of interest, I've provided a link above that'll take you to a video describing how to use that. So now we've got a new Conda environment installed on our machine called SimPy app. The SimPy model that we're going to use in our app is a simulation of an urgent care call center. Calls are going to arrive at random and queue up to wait for a call operator. Once they're seen by a call operator, they will be triaged, and a proportion of those calls will be referred to a nurse, and a proportion will exit the system. Those that see a nurse will queue up, undergo nurse consultation, and then exit the system. If you'd like to know how to build this model in SimPy, I'll link to a video that starts you off on that journey above. So within the repository, I've provided a file called main.py that contains just a simple script of running the simulation model that at this point has no Streamlit code within it at all. The call center simulation itself is contained within a simple local Python package called call center sim, where we have two submodules, the model, which contains all of the SimPy logic, and a bit of code to help us with visualizing the results and running some experiments in a module called output analysis. So main imports the experiment class and the multiple replications function from the call center package. Experiment allows us to vary the simulation parameters of the model and run it in a repeatable manner. And multiple replication will allow us to obtain multiple runs of the simulation, each with slightly different results. So we can look at the average result overall and the distribution. So this script contains some variables where we're setting parameters, for example, the number of resources, the inter-arrival time, and the routing logic, as well as some simulation run parameters, the number of replications, the warm-up period, and the results collection period. And we pass these to the experiment class where we set the parameters. Here, for example, we're setting the number of call operators in the initializer, and the multiple replications function where we pass the experiment, as well as our simulation run parameters such as the warm-up period and number of replications. And then at the end of this, we're going to print out the results data frame that is returned from multiple replications and describe that, so get the mean, the standard deviation, etc. of each performance measure and display that to the user. So let's run that code. So I'm in my SimPy app virtual environment. Make sure your terminal is in the same one. What we'll do first of all is we'll just check that runs. Excellent, that seems to have run correctly. So what we have here is a list of our key performance measures. For example, the mean waiting time for call operators. We can see that we've run 5 multiple replications. We've got the mean of that result and some results about the variation that we saw as well. So I like to lay my code out like this when I'm building a SimPy app. First of all, the experiment and multiple replication functions are almost like wrappers for the model. So this approach means that I don't need to worry about the implementation of the SimPy model at all. I just need to know what the variables are that you can vary within it, and also that the multiple replication function returns a data frame. So it kind of separates the logic of the model from the app, which is a nice place to be. So let's convert this script into a Streamlit app. So all we really need to do is import Streamlit as ST. ST contains all of the widgets and Streamlit functionality we need. So let's do something really simple to start off with. We'll add a title to our app. Now, if we save that, what we can do now is run our app in the background, and Streamlit works in a way where we can make modifications to our code, and the appearance of the app and the functionality of the app will be updated as we use it. So to run your app, you just need to use the Streamlit run command and the name of your Python file you would like to run. So here's our Streamlit app. We can see that it's running on local port 8504. Now, what's cool about Streamlit is we can make changes to our source, and those will be readily updated within our Streamlit app. So for example, if we change the title to save that file, you'll see that Streamlit prompts you that the source file has changed. So we can click on rerun and that will update the title for us. Now there's some settings available to us directly through the Streamlit app. For example, if we wanted to change to dark mode, we can go to settings and choose an app theme from the drop-down menu and switch to dark. Oh gosh, that's a lot better. I'm not sure why I was running it in light mode. Next, let's add some additional introductory material to our app. So if we head over to the resources subfolder, you'll see that I've included a markdown file called modelinfo.md. That just contains some simple information about the call center that would be useful to display to our users. So we've got a simple way of reading that in as well. Inside the app utility local Python package, I've included a module called file.io. In there, I've got a simple function called read file contents, which is going to open that file for you and read it in. And what we'll do is we'll use the st.markdown function in combination with the read file contents. And we're going to read from the resources folder and the model info the file. So let's rerun this. There we go. So we've added our markdown introduction to the model as well. So the first input widget I'm going to make use of is a Streamlit slider. That's going to ask us to include a label that the user is going to see describing what we're changing, the minimum value for that slider, its maximum value, its current value, and an optional step parameter that allows us to fine-tune the increments by which the variable can be changed. So if we save that, we can click over and rerun our Streamlit app, and we can see we've immediately added the call operators slider, and we can change that value and the model will rerun. So now we've got all of our sliders set up and we can vary those parameters. We can consider the remaining parameters of our simulation model, which are replications, the warm-up period, and the results collection period. So for these, I've generally found it a bit better to include a text box or a numeric input that users can type precise numbers into. So that's what we'll do here. We'll make use of Streamlit's numeric input widget. Let's rerun our file. Okay, so we've now got all of our controls to vary with our simulation model. So before we progress any further, it's probably a useful time to just have a think about what is Streamlit doing each time we change one of these input widgets. So let's change the number of call operators. So when we do that, we see this running animation appear at the top, and that will be the same if we change the number of nurses. Here we go, there's our running animation. So if we look at our terminal down here, we can see that the results of the simulation model have been displayed many times. And actually, when we change a parameter here and we rerun, a new set of results appears. So that's because each time you change an input widget, Streamlit will run the main.py file. So to visualize that, we're going to start at this line here, and the interpreter is going to run all the way down like this. And as it goes past the number of operators, the number of nurses, etc., it's going to pick up the current values of those sliders. So that's some of the Streamlit magic. And then as we get down to our experiment class, where we create a new instance, those parameters will be passed into experiment and will run a slightly different experiment and will print out the results. And at the moment, that's going to happen each time we change a slider. So we need to do something about that. We know. So we'll solve this issue by adding a button that we need to click in order to run multiple replications. So when the Streamlit app is reset, it will run down here and it will check, has that button been clicked? If so, and only then, will it run the multiple replications and display the results. So if we save that and go back over here and rerun our app, we can now change the values. And we can't even see the running symbol here. It happens so quickly. And that's because it will only happen when I click this button. So if I now click this button, we'll get the running animation here because that's because the simulation model is now executing. So it's not ideal that we're printing out our results in our terminal. So instead, what we'll do is we'll show the data frame within the app itself. So to do that, all we need to do is modify line 50, where we're looking at describing the results. So instead of using the print function, I'm going to use the st.dataframe function and pass in the results rounded to 2 decimal places and transposed. And if I save that and rerun, I can now run my simulation, wait for it to complete, and my table of results is now displayed to my user. So as we're using an app, it would be nice to include some interactive results for our users. So for that reason, I've included a plotly function that allows a user to select a performance measure and view the histogram of the results. I've included that function in the call center sim model package in the output analysis module, and it's called create user controlled hist. So what we'll do after we've run our results and we've plotted our data frame is we'll create that plotly figure. This function is pretty simple. All it requires for you is to pass the results in. Now there's some options to exclude columns and there's also some options to have user-friendly name mappings that we'll take a look at in a moment. We can pass that figure object to Streamlit's plotly chart function. If we save that and rerun, then run our simulation model, we get this plotly histogram underneath, and we can select the performance measure we're looking at. I guess one weakness is that we've got this kind of variable name, and we don't know the units for the different performance measures, so it's not ideal for sharing with someone else. So this function also accepts a parameter where we can map these names to some friendly names and units. So I've included an example of that in the app utility results module in a function called get KPI name mappings. And you can see all I've got here is a nested dictionary. So we've got the name of the dictionary, then the key is the performance measure name. So here we've got the mean waiting time, and that's mapped to a nested dictionary with a friendly name and units. So instead of mean waiting time, we're going to display call answer waiting time, and the units are in minutes. So let's import that function, and we'll modify our call to create user histogram. Okay, that looks a bit nicer. However, these results are sort of hidden further down the page, even on my desktop screen. So what we could do is move these controls to a sidebar. That's fairly straightforward to do again. So we'll open a with context manager for a Streamlit sidebar. And then all we need to do is just select the code that we would like to be within the sidebar. So all of these widgets, indent that, save it, and rerun. And we've now moved everything over to a sidebar. We can then run the simulation and we get a better view. Let's make a few more aesthetic tweaks to our app. The first thing I'm going to do is just show a bit of feedback to the user as the simulation model is running. So I'm going to add in a spinner. So this is going to display while the multiple replications are running. Once that's complete, I'm going to print out a success statement. Okay, that looks nice. Then what I'm going to do is I'm going to put these into columns rather than having them stacked as rows, and I'm going to put them inside an expander as well, so we can close and open them as we require. Okay, so we've created two columns there, and then for each column we've used an expander that's automatically expanded. We've got one with tabular results that contains our data frame, and a second one which contains our user-controlled histogram. So we can see that's a bit on the squished side, even if we hide the sidebar, and even if we expand the screen. So we're going to improve on that by modifying the page config. So this needs to come at the top of your file. So what this has allowed us to do, first of all, we'll give our app a name, a page title, but it's important that it's allowed us to set the page up in wide format. And it's also going to have the sidebar initially expanded. So if I save that and refresh the app and now run our simulation, okay, that looks a bit better. So we've got a wider app. And if we don't want to look at our histogram, we can turn that off or leave it on as required. So let's convert our app to have multiple pages, and we'll build a page where users can run batches of our experiments. So part of the magic of Streamlit is that it's really straightforward to do this. I'm just going to create a new directory called pages. In there, I'm going to create a new Python script, and I'm going to call that batch experimentation. I'm going to use capitals for this because this is the name that Streamlit is going to allocate to the page itself. So I've just imported some useful functions. So we've got our a function to create multiple experiments from a dictionary and to run all experiments, and some functions to provide a sample CSV file that we know, so we know what we can manipulate, and also a function to then summarize the results of all the experiments we run. If you're wondering where these functions come from, you need to watch our guide to experimentation in simulation. I'll leave a link to that at the top of the screen now. So if we refresh our screen, we can see now that we've got a multi-page app automatically. We've got our main page here, which is our interactive simulation. We'll do something about the naming of that in a moment. And we have a screen here for batch experimentation, which is currently empty. So the first thing I've done is add in a title for this page, some information about what we can do on this page, basically upload a CSV and run multiple experiments. And then I've also provided an expander, which is a template users can download. So that's using the create example CSV function to create that template and then displaying it as a Streamlit data frame. So if we save and rerun, we can expand and see that we've got some information about the template, which was just read in from a markdown file. And then we have our template file here, which is just a Streamlit data frame. And this provides a download as CSV button that we can click on. And you can see that's downloaded to my laptop. And then I can open that in my favorite spreadsheet package, in this case LibreOffice Calc. And if I want, I can add in additional scenarios here. I can then save that and potentially then upload it later on. So if we want to upload a file into our Streamlit app, we just need to make use of Streamlit's file uploader. So that's what we'll do directly underneath the template expander. So the first thing we'll do is just show some information about what our user needs to do. Then we'll create an uploaded file. So if I select that file that I've just downloaded and updated, you can see these are the experiments that I've loaded into my apps. So I'm going to allow my users to set the number of replications, the warm-up period and the data collection period here, so they can vary it each time they run a batch of experiments. So I'll also provide a button that allows a user to run these experiments in a batch. So we've basically, if a user clicks on the button execute experiments, we then pass the data frame of experiments to the create experiments function. That returns a dictionary of experiments. We're then, while a spinner's running, we're then going to run all of those experiments in one go. So this function is basically a big loop that loops through all of those experiments, and it's going to run each of those for the same warm-up period, results collection period, and number of replications. Then we print out it's done when we're complete, and we'll then also show a summary frame of results to the user. So let's try that. We'll try running it with the file that's loaded. And there we go, there's our results. So we only ran that for 5 replications. Let's run it for 10. And then if we wanted to get that down to our computer, we could click this button here to download as a CV. And those results would be saved on our local computer. Let's make some final reorganization to our app. The first thing I'm going to do is close down the app completely, because I'm going to create a new landing page for our app called Overview. In summary, what this does is it's essentially going to show a little bit of text information to the user using our title and markdown commands. But we have now a link to an image call center process in the resources folder, which is provided. And we're going to use the Streamlit image function to display that to the user. And we're going to put that within an expander as well. I'm going to then move the main script into the pages folder and rename that to interactive simulation. These numeric prefixes to the names of the pages just determine the order in which they appear within your app. So if I now rerun the app, but this time launch the overview page, we now have our app set up with a landing page that shows the process flow diagram for our discrete event simulation. Let's give these pages some icons to go next to their name as well. We'll choose an 8-ball for our interactive simulation because it's a predictive tool, and we'll choose a test tube here for our batch experimentation. So we just paste that into the name, and if we flip back to our app, we can see that that appears there. We'll do the same for batch experimentation. Okay, so that's our main pages set up. I'm also going to recommend that you include a license page within this that would, in this case, it's going to show the MIT license for our software. So you can see that's a pretty straightforward page. I'm just importing Streamlit. I'm using our read file contents function because we're going to read from that license file, and then we're just going to show that as markdown on the screen. Okay, so there's our MIT license. And then lastly, it's useful to also have an about page, and it's kind of up to you what you want to include in there. You might include, for example, a video that shows how the app is used, or it might be links back to your organization or research institute to describe what you do. In this case, what I'm going to do is include a video of how we created the simulation model that went into this app. So the code again is very straightforward. For an about page, we've just got the title that we're showing, and I've included a link button here, and that's just going to launch the Open Science Nerd channel. And then we've got a URL to the YouTube video that shows how this simulation model how you start building it. And we use the Streamlit video function in order to display that on the screen. So if we save and then go to our About screen, then our YouTube video appears here. We can click on that and start playing it. And again, we can use emojis here if we want to. So you can deploy your app for free to Streamlit Community Cloud. The eagle-eyed among you will have noticed the deploy button here. However, there's a couple of things we need to do before we click on that. The first is that you need to make sure that your app and your code is available in a public GitHub repository, because that's where Streamlit Community Cloud is going to pull it from. Second, you need to make sure that you have a requirements.txt file that Streamlit Community Cloud can pip install so that you have all of your dependencies in order for the app to run. That includes SimPy in our case, Plotly, Pandas, and numpy. So when you have all of that ready, if you click on deploy, it will ask you to deploy now. You'll need to choose the repository, the branch, and the main file path. In my case, this has been automatically populated for me. And you can create a custom URL. I'm going to call this osnerd-simpy. And then I'm going to click on deploy. The first time you boot up your app, it may take a few minutes for it to work. You can see what's going on by clicking down in the corner here where it says Manage App. You can see here it's installing all of the requirements for our code. And now we're up and running. And let's test we can upload a file and execute it. Here's our experiments. Now that your app's deployed to Streamlit Community Cloud, you've got a custom URL that you can share with your users immediately. This means, for example, that they can access it via their phone. That's quite useful if someone's very busy and they can't get to a computer. They can quickly have a look at your app and give you feedback or use it for their real job. In my opinion, Streamlit's a game changer for Python web development. It's really simple. You can build your apps super fast, and it's really powerful. I think it's going to make a big difference to research and industry and enable people to share their work a lot more widely, which is kind of what I want with this channel. So if you've got any questions about the video and the simulation model that we use, please feel free to put those in the chat, and I'll see you next time.